Okay, so let's discuss a question from riveted joints. So here basically what is given is a lap joint where two plates are riveted by means of a lap joint, and the diameter of the rivet is given. The clearance between the hole and the rivet is given. Okay, so the shear and the crushing of rivet material is given. So we consider, so these are the two possible modes that we need to analyze: the shear failure by shear mode as well as failure by crushing mode. So if it has to fail by shear mode, then what is the load that will fail? The load P that will fail. Remember that when P is acting, all these 6 rivets will be in shear and taking equal load. So and will be stressed to a same point. So tau is the shear stress into area of cross section of one rivet into number of rivets. So tau into A is the shear load acting on each rivet, and because it will be shared uniformly, so into N. So that will be the load P at the time of failure. So tau, sorry about that. So tau into area of cross section of each rivet, that is pi by 4 d square, into number of rivets, which is 6. So this is the shear load that will cause failure. Okay, the minimum shear load unit which will cause failure. So tau is 100 into pi by 4 d square, which is 7 square, into 6. So this we get when you calculate close to 23.09 kilonewtons. Okay, this is by shear. Now let's compute my crushing. If it has to fail by crushing, how much will be the P? Now crushing, what you have to understand is that when you have a rivet like this, okay, and when you have a plate like this, there's some clearance here and here. So crushing is basically because of the local compressive stress. Remember that when you have a hole here and the hole is bigger, and this is the hole, let's say. Okay, so when you are applying a load like this, the entire rivet will not be in contact with the plate. If you look at laterally, only the portion, like you are applying load in this way, so this portion only, the left half of the hole only will be in contact. So this is like a uniform pressure P, and so crushing basically is a failure by this local compressive stress. So how do you get this crushing load? So this crushing load, how you get is basically this is my crushing stress, which is nothing but just like a fluid pressure. So this stress into the overlapped area. I mean, if you resolve it, this area will be, this is diameter d, okay, into the thickness t. So the net resultant load because of this semicircular distribution of load will be basically the the projected area of this circular, of this semicircular. The projected area will be a rectangle of width d on the top, as well as it's acting throughout the thickness. So d into t is the projected area. So dt into sigma, just like when you do in fluid mechanics, dt into pressure. You want to find out the total horizontal force. So total horizontal, because vertical will cancel because of semicircular distribution. When you have a uniform pressure or a uniform stress acting, so the vertical will cancel, the top half will cancel the bottom half, only the horizontal will be there. So the horizontal force will be the pressure into, or the stress here, into the projected area. The projected area is diameter into the thickness. So this is the crushing load that is supported by each rivet, and there are number of rivets is 6. So crushing load will be number of rivets into the load which comes due to the crushing stress, sigma is sigma dt. Okay, so remember that we need to take diameter of the rivet, because on the rivet is what the stress is acting. So 6 into sigma is 150 into 7 into thickness is 5. So this comes out to be 31 kilonewton. So when the minimum, the load that is safe is the minimum of these two, because these are two different failure modes. So the minimum will be the one which will be the safe, right? Because if you apply more than 23, let's say if you're applying 25, then it will fail by shear. So the idea is it should not fail by shear as well as it should not fail by crushing. So you have to apply the minimum of that. So 23 kilonewtons, 23 to 23.1 you can say, is the answer. Okay, so 23 kilonewton is the answer. Thank you.